for you. About the signaling system, I'm going to go fast on some of these. So if you guys want to follow with me, go to chapter 7, please. Signaling system, talk about the fire alarm at the end and a couple of things. The first thing, Ashley, you were asking me when I did your low voltage guys risers. You were talking about morning Alaribo. You were talking about the master clock system. We'll talk a few things about the master clock system. They have a master clock system in our project. How does it work and the science behind it? You guys read it on your own. We'll talk a few things about it. There's a program system. They call it a program system. Kind of similar to the paging system, except it goes directly related to the manufacturing. So you can call for brakes and call for anything you want. We'll talk about that so-called program system. Then the typical paging system, guys. And the last system that they have in this is fire alarm system. So these are a few systems I would like to touch on very quick. Master clock system, I'm going to go directly into this. Master clock system, guys, there are two ways of doing it. And I'm not expert, correct me by any time, you're an expert, Chris. There are two ways of doing it. Either you have atomic clock like this one or digital, which synchronized directly with the satellites or with the signal that comes from Arizona or somewhere. They send the signal. Colorado, thank you. From Colorado, send the signal, synchronize them direct. And they are battery operated, thrown on a wall, done deal. The second system, or the same system, is to have a master clock powered, say 120. You get the master clock 120 powered here, and then wired to display unit. So these will be just a display unit. It's the so-called the slave. So the master will be here, master clock that running the time right in here, and it send the signal on these wires to these display units to give you the time. So each one of these will be so-called display units. These, my understanding, Chris, they can come wires or wireless, wired or wireless. So you can, and again, my understanding of this system, guys, is say if you work in a building and there's a lot of floors under, a lot of stories under the ground, underground stories, 2, 3, they might not be able to directly receive a signal from Colorado. So what they do, the smarter than Chad, they put an antenna here, some type of an antenna, and they grab the signal, put this on the roof, they grab the signal from the roof and they bring it down to this master clock system. And in the master clock system, it display it either wired or wireless to all these display units, wired or wireless to this display unit. For our project, guys, when I ask you about master clock system, you're going to show me something similar to this with wires, or I ask Ashley when she did it, or you don't get rid of the wires and just show a little symbol like this to indicate that this will be a wireless system. So either with wired or wireless. So you look at, this is your master clock system riser, that's it, wired, or get rid of all these lines, all the lines are off, and just add this little symbol to indicate that it will be wireless and you're done deal. Yes, sir. Yes, you need to power that device. Every electronic device needs a power. These are battery operated most of the time. No, you don't need power for these. Battery operated. So you change the batteries and off it goes. It receives a signal. Any question, guys, about this clock system? Can I get you a lot to draw something similar to this for your clock riser? That's all. So how the system works, a couple of things, guys. They talk about the drivers, number of units to drive, the display units that we talked about, this one. Here's one way of displaying it. LEDs, what else better than LEDs? To indicate the time that can be seen. So that's your LEDs. There are a couple of things about the size of the letters that you have to do and so forth. In these display units, you can read them on your own. How the system works. They're talking about, this is the brain. Chris, as a Nick, my friend, this is the brain. These are, in this application, these are dumber than rocks, basically. The brain is in the master. How does the brain work? The brain works through methods. They have a so-called synchronous motors. Everybody knows the difference between synchronous and induction motor. Synchronous motors, they run if it says 1800 RPM, they run completely at 1800 RPM. An induction motor runs slightly less than a synchronous motor, so there will be like 1750 RPM. So long story short, the motor will run exactly at the frequency that's injecting into this motor. And you know what, everybody knows why they use a synchronous motor, because synchronous motor is accurate. If you need anything accuracy, they run a synchronous motor. So they grab the synchronous motor, a speed. So the speed of the synchronous motor is proportional to the number of poles, and of course the frequency. N, what is it, the formula? N equal 120 times F over number of poles. You guys remember that? Number of poles? We'll talk about this one. N is the synchronous speed multiplied by 120 is a constant. Frequency is 60 hertz. Number of poles is either 2, 4, 6, 8, or how many poles? North, south.
This is totally obsolete. It's like talking about steam engine.
Absolutely. So, so that's one way of doing it. One way of doing it. Now with the technology, you're absolutely right. With the technology, they're moving to a whole lot of different ways of doing it. So this is a motor. I think the obsolete stuff that we're talking about, I think we have and we are done with. No surprise, huh? So a motor-driven synchronous machines. Now with the technology, this is not what we're gonna do. Okay, so the other one, guys, you have the 60 hertz line frequency. It takes a 60 hertz to do it. And look at this, minutes per month is the accuracy, so it's not inaccurate. So you can lose a couple of minutes per month. If you are Chad Kearney, you don't care. If you are Nick and you really want the seconds, it's a big deal to lose a couple of minutes per month. So that's an old technology. A couple of other technologies, guys, that they use, they call it the crystal, the quartz crystal. It vibrates, they sense it by vibration instead of running a motor. My understanding is they sense it by vibration. So we have the way it works, you have a crystal resonates pieces, it resonates, and by resonating, they can capture between the two plates with the frequency that's coming from an AC again. That resonation or resonant frequency is how they capture the time. So resonant frequency, extremely constant, so you don't have the fluctuation. And here's the accuracy for this system, a couple of seconds a month, not a big deal. I'm not too concerned, guys, about the technology and all this good stuff. The newest technology is more digital, more satellite oriented, either stay alone system, like we said. These display unit, most likely it's not going to be a synchronous motor. Most likely it's going to be a digital electronic clock system. Receive a signal from the satellite, display it to the display units via wired, most likely wireless. Most likely wireless. Okay, so that's the two technologies that they guys have. So that's about it in terms of the clock system. In our clock system, guys, please do me one little favor. We're going to have a master clock, an antenna somewhere outside. I know we might not need it in a two-story building just to get into it. Tiny little symbol of an antenna coming to a master clock. From the master clock, we go wireless to the display unit, which is in our case, what was it? 12 inches, Chris? And 15 inches. 12 and 15 inches. Any comments, guys, about the clock system? So really, it was a big deal, guys, when it was synchronous motor and how to run them and all this good stuff. The second system, so that system standalone, Chris, clock system. Most likely digital, most likely interface wireless with display units, get a signal from the satellites, and to synchronize the time. This system, they call it program system. This is directly related to manufacturing. This system is, it's a way of communicating with your blue collar type of worker. So they're working on an assembly line. How are you going to communicate with those guys? So, well, there's a horn. You can blow a horn, or you can ring a bell for them, or you can have a couple of buzzers to indicate the start and the finish of every shift, the lunch time, the smoking time, do they have smoking time, or the break time. All these you can indicate them by different horns, bells, or buzzers to communicate. Mostly, Chris, help me here, mostly with blue collar people. I mean, you don't do this in an office. Michelle Cooley is not going to have a buzzer. I have a story about an engineering firm I worked for. My first career, they have actually a bell that the secretary used to walk in Have you ever worked in a place where she rings the bell around 10 o'clock? That indicates it's a 15-minute break. Are you kidding me? And then it was, I think, at 2 o'clock. She rings it again, that indicating it's a 15-minute break. And everybody will go around the big table. They sit there and chat, all engineers. And that's an engineering firm. They're no longer in business, and I'm not surprised that they're not longer in business. They got absorbed by others. So anyway, they did high voltage, but good stuff they did though. Okay, a couple of things at this, the beginning and the end of shifts, very important. Lunch period, breaks, smoking breaks, or any breaks that you need to do. Okay, so plants, different plants, proper timing, and so forth. So these are what the system that they have, guys, in this building. This system has a brain, like all other systems. You guys are looking at the fire alarm system. Every system starts with a digital display unit where you can program and again, I'm not a really control engineer. Every program, fire alarm system, guys, security, phone data, start with now, these days, microprocessor device. With eyes, they call the inputs, and hands called the outputs, and a couple of ways of programming it. This one is no difference. You have a computer, so-called computer microprocessor device, based timer can be, and then that's your controller. Then you have a way of programming it. This one can be programmed via the screen at the top here, the push buttons as a controller, or you can have an interface, another device that interface with it. Okay. If you're in a situation like this, look how many events you can do in this system. Almost 1,000 events. There's a couple of things you can do. Cyclic events can be programmed by you. Every minute, hour, day, week, year, you name it. Can be turned on. There's the system that they have is 24 output channels that can be turned on at any time. So you can signal, guys, so many things out of that system. Signal the lunch, the start, the shift, and so forth. So look at them on your own. Then the programs are saved as cassette tapes. I don't know if you use cassette tapes recorder anymore. They probably don't. They digitally record it. Program timer. They have a digital timer. Thank you for the digital clock that they have over here. They probably will digitally record everything now. Okay, battery backup. It's very important, and battery charger. Typical, guys. All these systems, fire alarm, security, phone, signaling system, they all come up. I don't have the battery here. With battery backup that can be charged. Charged battery backup, just in case of failure of power. Okay, so that's your so-called program system. Any question, guys, about the program system? Typically associated with manufacturing floors. We don't have I didn't ask you guys for our project. We did not ask for a system, so to speak. We're going to use the paging system to do all the signaling, the start and the end of the shifts and so forth. The last system they have, guys, or the one system before, is the paging system. Any question, guys, about the clock system, the program system, and the system, the paging system? We talked about paging system, guys, because we're going to be doing it. Convey messages to the people in the plant to move, remove, walk, do whatever they want to do. So you guys were required. We had our speaker, and he said, Chris, when he was here, well, he and before him, and again, I'm not an expert in speakers by any means. My rule of thumb that I heard from the so-called the experts is you have to have 2 speakers in every space, public space. At least 2 speakers. We placed them from 30 to 50. I heard 30 to 50 on center. At least 2, and they placed them 30 to 50 on center, depending on how many watts each one of them and so forth. When you do a paging system, a couple of things you have to be concerned about, guys. Area that you need to cover, obviously. The number of paging units that you need. I said 2 units minimum, right? That's the kind of the rule of thumb that we start with. 2 units in every public area. No private offices, public area. So lunchroom, hallways, what else? Public offices, open offices, what else? Conference rooms, but no private offices. No private offices. No bathrooms. Bathrooms, 1 maybe. Electrical room, If it's a closet, no. If it's an electrical room that they can do work there, it's a good idea to put at least 2. So you guys get the rhythm of these, 2 at least, 30 on center. Also, because whom am I going to pick on? Alaribo, you have to always pay attention to expansion in the future. If you want to expand, so you have to give more modules to your system. The paging system should, what do you need to convey? Voice, tone, or a combination of both. You can buzz through the paging system or talk or do anything else. We have an explosion-proof NIC location on us, so you have to pay attention to an explosion-proof equipment. You cannot put anything in an explosion class 1 Div 1 location unless it's explosion-proof. So you get the speakers that you put in your plant when you submit to your friend Chad. If it's not keynoted and says explosion-proof equipment, you will get your D- and move on. Oops, did I say that? So explosion-proof or weather. Obviously, if you're doing it wet, damp location, you have to pay attention to it. Ambient noise level is a big deal. If you are to have a speaker where Chad Kurdi exists here, you're talking about probably 50, 60 decibels coming out of my mouth right now. So, so that's my understanding, guys, and I'm not an expert from listening to experts in that. They say in order to hear something clear, Chris, you have to be 15 decibels above the ambient noise. So if the ambient noise, guys, right here when Chad is shouting is 50 dBs, is that what they call it, 50 dBs, I have to add another 15, so I have to design a system when Chad is talking to be, what would that be, 65 dBs, is that what they call it? 55 dBs in order to clearly hear the individual, decibels. 15 above the ambient. Now, what's the ambient? Here's a couple of things to help you with the ambient, guys.
I got 5 on 4.
5?
I'm used to 6 health communications. Bell Labs uses 6.
The number that I stuck in my mind from an expert, 6. Is it saying 5 in the book? 5, 6, whatever. So the number that stuck in my mind from an expert is 15 above the decibel, the ambient. Okay, ambient. Here's your ambient, guys. Very quiet person. Who's the quiet person here? Ashley. A very quiet person like a whisper, that would be probably 30 dBs, whispering. It goes all the way up to an uncomfortable loud like a saw, a circular saw, jackhammer, God forbid, thunder. So you can see here, the largest one is 195. That's uncomfortable, could provide pain to your ear, and in between. So where's the moderate? The moderate is 75. When Chad Kurdi is talking, probably you're looking at 80 when I'm loud. So this will give you kind of an indication where to put. So industrial plant for ours, guys, going to go to the upper limit, and then based on Chad, you add 15, or if you have another system where you can add 5 based on Chris, or 6, let's say 6. So depending on what system you use, you add 6 and you design your DP system. Any comments, guys? Any questions? The ambient temperature, you add from, let's say, from 6 to 15 extra dBs, so you can hear clear. Any question about the ambient noise, though? Ambient noise, like ambient temperature. Okay, correct me here, Chris. They say, and when you put your paging system, guys, every time you double the distance, look at this. Every time you double the distance, here's 10, the distance is 20. I went from 10 to 20, you lose 6 dBs. dBs. Every time, right? So every time you double the distance, you lose 6 dBs. Rob, this is very important when we go to Cummins Tour. When we go to Cummins Tour, guys, they're going to tell you about when you have a generator outside, guess the first thing you put a generator in your backyard, the neighbors are going to do? Complain about the noise. So you have to, so you get into how are you going to minimize, I can't remember what's the criteria for at the property line. Do you have to be, the city's required, I can't remember, is it 30 or something? I can't remember the number. So you're going to go to the property line, and the inspector will come, guys, with a DP, with a noise measuring tools, and they will measure the noise right at the property line. It has to be within that limit. Otherwise, you have to provide an attenuation enclosure. They call it attenuation enclosure. So when we go to comments, please remember that they will tell you in order to solve the problem and have a cheaper attenuation, noise attenuation enclosure, to solve the problem, they double the distance from the property line. So for example, every time if you are 10 feet away from the property line, you move it in another 20 feet, or move it to a 20 feet from the property line, you reduce your dBs, the noise, by 6 dB. So by moving it inward inside your property, if you can, you might be able to get away with less attenuated, noise attenuating enclosures. Who cares? Dollars. Yes, Nick.
Generator. Now, when you're talking about the generator, though, it's only going to be running when all hell breaks loose.
It doesn't matter. If you have a generator outdoor, you'll see you have a generator outdoor in a residential place. In a lot of ordinance in the cities, you have to meet for commercial air, especially commercial generators. You have in a residential area like Commons. When we go to Commons, they get you into the regulation, noise regulation. So anyway, can I get you guys to understand that one? Every time you double the distance, you reduce your dBs by 6. Can I have thumbs up from Tao? Yep. Okay, so that's it. So I went from 80 here all the way to into 160. Then you cut it from 92 to 86. You go 6 dBs. Any question is about what this curve means? Cutting the dBs, 6 dBs every time you double the distance. Every time you double the distance. So every time you lose 6 dBs, 6 dBs, 6 dBs, 6 dBs, 6 dBs. And you can see how the 6 dBs, you can, by the time you reach this point here, 1, 2, 3, 4, 5, 5 times 6 is what? 30, right? So you lost 30 dBs from 110. That's a big deal. But we went from 0, right? Or 10, was that 10? Yeah, from 10 all the way to, we pushed it back 320 feet inward to lose that amount of dBs. Any question, guys, about losing dBs by doubling the distance from the point you measure the noise to the point where you put your equipment? Very important. This comes, now this is for noise attenuation as well as for, now noise, we want to cut it down. But if it's paging system, it's a big deal because it's the opposite. We want to be able to hear it. So pay attention when you lay out your, if you become a low voltage contractor or a designer, pay attention to this little rule. Any
rules apply resident. If you have residential and you have paging, you have to be careful about sound infiltration. Same deal with generators. You may have to put timers on that say after a certain amount of time, the PA must not be
that loud, so it doesn't, control it by timers. Okay, your paging system, guys, can instruct employees to do certain things under emergency situations or normal situations. Here's what they can do. They have all these signals that they can come out of whale, conventional siren, high-lows, and whoop and horns, and each one of them has its own explanation. We have a couple of things that we supposed, if we have an emergency done with our paging system, supposed to give a signal. I can't remember what signal. But you can signal all these through your paging system. Any question, guys, about the paging system? 2 things to remember. 2 speakers in every common area, public common area, and the 6 dBs that you lose every time you double the distance. And planning for the future and everything else. Because if you're a designer, always ask yourself, is the environment where you're going to put the speakers and so forth. Any question about the speaker system before I jump into the fire alarm system? Chris, did I miss anything? I know you read the chapter. Did we miss any important thing? They have a couple of pictures. I'll show you guys a couple of pictures here. But okay, fire alarm system. You guys are looking at fire alarm system right in here, right in front of you. This happens to be addressable fire alarm system. The first thing you have in a fire alarm system, and feel free to wire it. If anybody wants to wire it, I can help you wire it. We wired these before. Our electricians do. The brain, the controller. So CCU, they call it Central Control Unit. That's the brain. You have a couple of interface, guys. You can program it right in here. And I think they have a place where you can't remember if this one has it. You can plug into it. There's a key where you can activate it for testing here. If you look over here, testing, you have a place where you can program it. So this is the brain. Like every other system, guys, every fire controller has first the brain. This is the fire alarm control panel. That's your panel. The brain inside it, and all these blue crests that you're looking at this side, they call them what do they call them, Chair? They call them the NACs. The NACs, and these are called what do you call it? Let me get it. I forgot what. The signaling circuit, SLCs. SLCs and NACs. NACs is the notification appliances circuit. Notification appliances circuit. So you can wire with this bunch of wires here, two wires, one positive, one negative. You can wire your horns and strobes and solenoids and anything that you need to announce the existence of wires. The NACs, they call them NAC circuit. Two wires. From this one, the signaling circuit, guys, this one, you can pick the smoke detectors, the horns, the smoke detectors, the heat detectors, the flow switches from this side, the inputs. So inputs here, outputs here, the brain is here. Here's all your inputs. Contacts is another output here for a door that you can open and close and so forth. So this is a typical, you can come over here and look at the wiring diagrams for it. I don't know if you guys can see right in here, there is a battery supposed to be sitting right here and wired somewhere. I think somewhere where battery is, I can't remember where, I have to look at it. So you have to have the batteries powered here, and you bring the power, the AC power into it here, and you set your battery that's going to be charged right in here. The battery looks like it's coming from from somewhere here. That must be the batteries. Okay, so you can put your batteries back up here. Control inputs, controller, battery, power, and all the initiating devices in between. Any comments, guys? Any questions? This happened to be a digital addressable system. And I don't want to make it fire alarm class, guys. A digital addressable system, all what you're taking is just two circuits, two wires. Well, 2 or 4 wires if it's supervised. And you loop daisy chain, guys. What they do is they daisy chain all the smoke detectors. You can put almost unlimited amount of smoke detectors on a digital system. And they send the signal directly to this. So if there's a fire, not only it tells you that there's no zone. Zone, it becomes obsolete almost. Every single device can tell you where the fire started, not just by area, by device. If there's if one of them is to go off, it will tell you smoke detector number 15 in room number in the northeast corner of room number red 12, for example. That's your addressable system. The most common right now, first is the addressable system, digital addressable system, and analog addressable system. So that's the most common system they're going to be using. So that's basically the fire alarm system. You guys are designing it. I need a riser. I'll show you the riser that we're going to do. The rest of them is, guys, processors, and so you have the CCU or the fire alarm control panel brain that you have. Up to 100 processors can be connected to CCU. There's inputs and outputs modules, guys. Every time you need an input, you have to have an input module. One input module can get you, what did they say, depending on the system, 8 devices tied to one input module. Without getting into all these details, the processor can handle up to that many controllers. These controllers can be input-output modules. Input to get you the smoke detector, the flow switches, and so forth. Output, horn strobes, magnetic contactors, damper opening, and so forth. So that's a few things about your control system. You can interface. There's a lot of interface modules, guys, you can put in the fire alarm system. You can interface with motor control, shut down the air handling unit if you have a fire. Burglary alarm. Burglary alarm in, Chris helped me here, you did the low voltage. If you're at Home Depot, guys, and there's a fire, there are fire doors or egress doors that's always locked because of you don't want people to steal things and move out. These are completely locked and interfaced with the fire alarm system. If there's a fire, what the first thing they do, they release all these solenoids. They open all the doors. So wherever you are at Home Depot, you can get out from an exit. But these are locked though, so they have interfacing with a regular alarm system. Ground fault detection. If you have a ground fault in the system, could be detected. You can interface it with a camera too, with TV cameras, and so there's a lot of interface between this system and any other system all the time. Phone, you can dial the fire department, do a lot of stuff. Switch permit alarm to operate manually. Okay, this one here on the face, guys, they also have a way of testing. They have a switch auto. They have a little switch on it that you can test the system, put the system on test and test it. Yes, sir. Oh boy, did you hear this speaker that came here? Now they're using actually cameras. Well, I don't think that's what they meant here, but they're using cameras in smoke instead of smoke detectors. They're using cameras to detect the smoke. He was saying, I don't know if you guys remember when he was said, it's faster to detect the smoke with a camera than to detect it with a smoke detector, and it's easier maintenance. It's the least maintenance. But I don't think that's what they meant with this. I guess you can direct the cameras to, if there's a fire, you can direct the cameras to certain areas. To see what's going on in that area, monitor. I think that's what they meant here.
Force a security camera. Usually, if you have a security room in a large plant, you've got some guy that's paid $2 an hour, and he sits and watches the various things, and they just
forced to go to the fire area. Yeah. So it's part of the whole monitoring system. Okay, so the switch, guys, that permits you to operate the system manually or test it is also on the face of the fire alarm panel. All the inputs are smoke detectors, heat detectors, flow switches. You guys are very familiar with them from pull stations. You can come here. Nick, if you want to wire any of these babies, let me know. We can easily, not the digital ones, the analog ones, we can wire them and we test them. Audible alarms, that's your horn. Strobes, that's your strobes, and for the horns and the strobes, they have the Candela power 750 flashes per minute and so forth. Okay, so and we talked about, guys, where to put the horns and strobes. We have a criteria where we put them. We put smoke detectors 22 on center, right? 22 feet on center when we place them. Horns and strobes, we put them. We have a criteria for putting the strobes and the horns. All public areas need to have the horns. What else? Heat detectors. If an area the heat is an issue more than a fire, then a heat detector would be a great input device to your system. Flow switches, tamper switches, all these are input devices. Okay, here's everything that you see, Chris, my friend here. Everything, let me just see. Okay, input everything, just not to confuse you. Right in here, go all the way, Chad, here and here. This is your fire alarm control panel. So Nick, everything that you inside that red line is what you're looking inside that box. Okay, so inside the box, we talked about the processor, the box, that black box is these two together, and then you have the power modules. These 1, 2, 3, they're actually part of that big black box in the front of you. And then the controller in this one is also part of that black box in the sides. And the controller, guys, have multiple inputs. I think they were saying 8 inputs to a controller, inputs, outputs.
This is to a specific model.
Yes.
No longer made.
And there's so many inputs. There's so many inputs in digitals and so forth. And then here's your output devices. It might not be made as an input module. All these could be part of your microprocessor. You still have to have input modules, but part of your microprocessor or processor. You have your strobes. You have your pull. These are your inputs. Smoke detectors. These are, what do they call them? NACs. Notification appliances circuits. This is circuit number 1. Actually, remember when you were showing me what you did? This is a NAC. See how you bring a NAC to a module, and from this NAC you can go to another strobe and a third strobe. Here's one NAC number 1. Multiple strobes going to NAC number 1. And then you go to the controller, and here's So this is output strobes. This is input. This is SLC signaling. SLC, signal line circuit, signaling line circuit. I think stands for signaling line circuit. In an addressable system, SLC1, this is your circuit number one that goes um, into the smoke detectors and the input devices. Bring the input devices. So you have your NACs and you have SLC in an addressable system. Non-addressable system, input device circuit. I think they call them input device circuit. This is equivalent to SLC. Input device circuits is for a non-addressable system. IDCs or SLCs in the input, NACs on the outputs. Okay, so I want to bring to your attention, Chris, my friend, that you are interfaced with the paging system through an output module. And of course, everything needs a power. So what they do is they provide a 20 amp circuit with number 12 conductor to feed this circuit, dedicated circuit for this equipment. That's about it. And the rest is more input modules as part built into the system, or more output modules that's also built into the system. Any question? When you guys do a riser for me, Chris, when we do a riser, everything inside that red box, I don't want to see. I want to see a box right here inside this red lines. I don't want to see the details there. All what I see is just a fire alarm control panel and all the outputs and the inputs and the powering it and the interface with the paging system. We will leave the inside to the specialist, the smarter than Chad. Any question, guys, about the fire alarm system? So that's your fire alarm system. I think that's all what I have for you. Let me just see if I flash a couple of nice looking pictures for you, so you can. So we got this one, guys, about this the display units. We went through that one. We talked about this, talked about this, talked about this, and the rest of them, guys. All these timers and a couple of pictures about the paging systems and the horns and the strobes. Feel free to look at the material. And here's the modules that they're talking about. I don't know if you can see it. Now, I don't know if this is the most, this one does not look like the one that we have. This is because this is digital system. This is a digital system. But I don't know if you can see 1, 2, 3, 4. These are your inputs or output devices, point automated. So this will make your input or output devices. Yes, please.
So on the output side, let's say, what tells us, or what tells the electrician of how many we can place, and what are we running for voltage?
24 volt on the input and the output, and how many devices is based on this. If it's addressable system, if you read about addressable system, you can put hundreds of smoke detectors on one SLC.
So you don't have to worry
SLC.
about voltage drop.
If you use number, they don't consume, they consume milliamps. Milliamps. What they do is then you can, if you use number 18 or number 16 conductor, 16.4 or 18.4, you can. And again, I'm not an expert in fire alarm system. I bet you can put in an addressable system, you can put close to 100 on one area. Now, the more you put, it's like putting all in one basket, all your eggs in one basket. Of course, you would have more SLCs, the signal line circuits. More of these, the better. Like lights. Do you want to put all your lights in one circuit, even if you can? It's not a good idea. So you group the areas into a bunch of SLCs, and probably I would say if you put 30 to 50 devices on SLC, smoke detectors, horn strobes, smoke detectors in this one, that will be a good design. Again, that's my 2 cents on that system.
Yeah, the problem, if you're short one, you short them all.
Well, if you short one,
on a given circuit, that's
yeah,
why you want to.
yes, yeah, there are two, yeah, there are 2 systems. There's one system, what do they call it? Supervised system. Supervised system, guys, they take 2 wires, positive and negative, and they took another 2 wires, also positive and negative, and they tie the devices right here, positive, negative, and they come from here to another device, positive, negative, and they go all the way to the panel. So see how many wires they're bringing? They're bringing a loop. So if you are to short in one side, or have an open circuit in one side, you will, there's certain faults that you can feed either from this side or from this side. So if something to happen to this wire here, you will alarm and continue to work on these. These are, my understanding, required for hospitals. So if you have an open circuit condition in a fire alarm system in a hospital, you want to be two things able to. The rest of the fire alarm components need to continue to work properly, and you need to be able to alarm upon the loss of an SLC. Anyway, so that's when you use 4 conductors versus 2 conductors circuit supervised in certain application, and I really don't claim to be an expert in where they put them. A couple of devices, guys, here, and that's about it. Any comments, any questions about these? Very quick overview of the low voltage system. Any questions? If anybody want to fire, not this one, the non-addressable one, we can fire that baby. The common thing about, guys, about any low voltage system, very common, very simple thing. Controller, inputs, outputs, you have to power it with 120 to power the system. Always, you need to provide, almost always, a 120 backup batteries. That's a power. Backup batteries with power. The controller, the inputs that senses what's going on, the outputs that initiate the decision that has to be made, and inside it you can program it by hand. And in this day and age, I hate to say by hand, because you can use your iPhone or smartphone to program anything. So
Does it get fed by the UPS?
Fed by the UPS? You can, but it has its own battery. It really, what's the UPS?
Oh, okay.
Yeah,
Gel cell battery.
it's already have a battery by itself. You can feed it from the UPS. If you have a UPS, you can sit on it. There's nothing says that you can't, but really, you already have a system. Okay, let's take, guys, 5 minutes break and switch tracks to a different topic.